Greetings, my name is Kuberan Magindran. Today I will explain to you what is magnetic resonance imaging. Magnetic resonance imaging, also known as MRI, used by medical hospitals to acquire an image of an internal organ of a human body. This is a non-invasive method that is used by physicians to know actually what's wrong inside the human's body. And an MRI machine consists of three parts. The main components in the machine is the scanner, the computer to communicate with the scanner, and finally a recording hardware to produce an image of what is being scanned. The MRI machine is large and it's built in the shape of a big tube that has magnets. The main component of an MRI machine is its scanner, which consists of many magnets built around it, and then it has a computer connected to the MRI machine for communication, and finally a recording hardware connected to the layout of the picture scanned. In the large tube consists of many powerful magnets for static magnetic field. So when the gradient coils and RF radios works, it will communicate with the computer and produce more detailed imaging of a scanned organ. To obtain an MRI image, the patient must lie inside the tube. This process requires the patient not to move so much as the image can blur out. So if the patient has claustrophobic problems, they will be given sedative to make them feel calm. So for this detailed image to work, a substance called a contrast agent is given to them. So what it does is that this agent consists of gadolinium, element of gadolinium that's injected into the patient, which then mixes with the patient's body fluid and makes the proton speed faster, which gives the RF radio frequencies to pick up the speed and also print out more detailed images of what's going inside the human's body. MRI machine can produce cross-sectional images of the organs inside the human's body, such as the size of a tube wall, of an artery, or maybe inflammation of blocked vessels inside the brain. So it can produce a cross-sectional area to identify the problems or any abnormalities inside the organ.
Greetings, my name is Liu Minze and I'm from Group 17. Our topic is about magnetic resonance imaging, and I'm going to talk about the problem statement in our assignment. Since MRI is used in 20th century until now for medical purpose, we have found that MRI has improved a lot, but there is still some problem that need to be improved on and being solved. For first, we study about how MRI is designed and process of innovation with concepts that it relates to electromagnetic field theory. Next, we study about how MRI contributes and its impacts towards the public health and environmental safety. And last but not least, we also study about how MRI works and what are the potential problems that need to be improved on so that we can use MRI more efficiently in the future. Thank you.
Hello, my name is Kuhan Wira, and now I will present the designation or the process of innovation with concepts of electromagnetic field theory. As you can see, this is the image of the first ever MRI that was invented. At first, people were very scared of this machine. Therefore, engineers have developed the MRI to make it look more open and hospitable. Therefore, this is the modern MRI machine. There are 5 components in this machine. First is radio frequency coil, gradient coils, magnet, scanner, and patient table. For this MRI machine, the magnet is the most crucial part. The high quality image produced by the MRI machine is due to the function of the strong magnet and the calibration of the radio frequency coil. A horizontal tube called a bore is used to traverse the magnet. The magnetic force of a magnet is used to express in Teslas or Gauss. 1 Tesla is equal to 10,000 Gauss. Therefore, magnets used in MRI consist of magnetic fields between 0.5 and 2.0 Tesla. Current that passes through a series of internal coils in the magnet generates a magnetic field. This creates a superconducting state that releases a lot of energy by dropping the resistance in the wires to 0. The main magnet of the MRI machine has 3 different gradient coils located inside the coils. These produce 3 different magnetic fields, each weaker than the primary magnetic field. By modifying and regulating the primary magnetic field, the gradient coils provide a variable field X, Y, and Z that can be used to scan specific and unique body parts. Radio frequency coils. Radio frequency waves are primarily directed into the patient's body through the radio frequency coils. Within the MRI scanner, many coils are used to direct waves into distinct body areas. All RF coils often focus on the body part which being scanned when a specific area of the body is designated, enabling a superior scan. The patient is placed in the MRI machine on the patient's table. The table moves into the tube. The posture in which the patient lies determines which part of the body to be scanned and examined. The body will be examined as it lies in the center of the magnetic field produced by the magnets in the tube. That's all from me. Thank you.
Dr. Liu, I'm Liao Waiho from Group 17. Today I'm going to talk about the magnetic resonance imaging contributes to public health and environmental safety. An MRI plays a good role to contribute an early prevention or diagnosis so that we can get treatment early before the state of an illness is getting worse. While other ways of testing can sometimes show effective in the diagnosis, but the MRI can detect correctly many diseases and flaws even in their very early stages. MRI allows physicians and doctors to diagnose effectively and make sure that the patient will accept the appropriate course of treatment. By taking an early detection, people can prevent the worst situation happen, like terminal cancer. This is the picture of lung cancer by using MRI. For the pregnant people, it is normal for them to have an MRI. Pregnant people can get an MRI at any trimester. There is no harm to patients or babies, according to the documented reports. MRI can supply details that is measured to know before the baby is born. It can also provide figures about the developing fetus when ultrasound cannot. The baby's organ can be scanned by using an MRI to guarantee that the organs are growing completely and healthily to prevent dysautonomia. This is a picture of trimester pregnancy by using MRI. This is the picture of sampling location of wastewater treatment plant by the MRI. Gadolinium concentration in Tokyo rivers assessed by Tokyo Metropolitan University researchers documented elevated levels near wastewater treatment plant outfalls. 35.5 ppd is the average value of anthropogenic gadolinium, indicated a significant rise relative to data recorded 22 years ago in Germany.
For conclusion, MRI, magnetic resonance imaging, is a machine that can let the scientists to study our body, such as our brain structure and our skeletal system. And MRI can produce a high spatial resolution of image from the patient. But some people that have ADHD might not be able to participate in this experiment because the image must be let the patient to hold still for several minutes to be able to produce a high quality of the image. So with the aid of the drug, the person might be able to participate in this experiment and be able to produce a high quality of image from the patient body. And MRI is a machine that produces a powerful magnetic field within the ball of the magnet. So that can be able to let the magnetic field to align with our proton from the patient body while the patient enter the magnet. So the scanner produce radio frequency pulse interact with the patient's proton to produce signal, like I said just now. So when the radio frequency pulse produced from the scanner, the patient's proton will become excited and resonant. While if after the radio frequency pulse has been stopped produced by the scanner, the patient proton will become like some kind of relax, and we can get the result and the image from the patient from the scanner. And lastly, there are two types of MRI image, which is T1 wake and T2 wake image. So the difference between this image is that when the radio frequency pulse sequence only highlight the fat tissue in the image, that is what we call a T1 wake image. While T2 wake image have highlight the fat tissue and our water from the radio frequency pulse. That is the difference between MRI image for T1 wake and T2 wake image. That's all. Thank you.